Welcome to this video showcasing the new Digi Bridge from HV Diagnostics. HV Diagnostics is proud to announce the launch of this new unique piece of equipment that will complement our existing successful line of medium voltage and high voltage cable testing equipment that we offer. With this new product, the cable engineer will not only be able to perform the very important task of testing the integrity of the cable jacket of medium voltage and high voltage cables, but if required, also be in a position to locate faults in both the cable jacket or the cable installation itself. Why is cable jacket, or as they say in many parts of the world, cable sheath testing important? The cable jacket provides a very important mechanical and environmental protection layer for the cable. This is not only important during transportation and handling of the cable, but also during the storage phase, installation, and throughout the life of the cable. The service life can be severely curtailed if the jacket is compromised. The cable jacket serves to prevent damage to the critical layers that lie under the cable jacket itself. These include the metallic neutral shield, the semiconductor layers, the dielectric insulation, and the conductors themselves. In the short term, this damage is often caused by more mechanical forces, such as using excessive force during the cable pull, or a rock that falls and penetrates the cable jacket during the trench backfill. In the medium to long term, cable jacket damage can lead to more chemical, electrical degradation processes, such as corrosion of the neutral metallic components due to water ingress into the cable system. Water ingress can also result in failures of accessories and ultimately the failure of the cable insulation through water tree growth, tracking, or general water degradation. These can cause operational, safety, and reliability issues for the cable owner. There are very few products on the market that have this form and functionality, with a brilliant sunlight visible color display, a clear, logical, and informative user interface, a special high voltage rated pluggable cable interface, industry-leading capacitive loading capability. The Digi Bridge packs a lot into a very compact Pelican case that is both portable and lightweight. It also houses a very powerful integrated battery that provides more than 10 hours of operation without the need for shore power. Historically, bridge techniques were often used to locate cable insulation and cable jacket faults. However, the use was often restricted and limited due to the applied voltage capabilities. The skilled operator was also required to correctly set up and interpret the bridge, and because fault transient techniques using thumpers were developed that were easier to apply and use in the field. With modern electronics and artificial intelligence, the digital bridge, or Digi Bridge as we call it, provides the user with intuitive, logical user interface with everything they need to correctly set up the instrument and connect to the cable. When these thumper fault transient methods don't work, like on resistive faults or dead shorts, also known as bolted faults, or on aged tape shielded cables, bridge methods allow the operator to locate the exact position of the fault. In addition, when cable owners want to limit the potentially damaging amounts of energy injected into a cable fault using typical thumpers, the low energy bridge is an excellent solution to locate the position of a fault. There are three modes of operation with the Digi Bridge. The first mode is the cable sheath jacket test. This test is used for the cable that is direct buried or cable that has the outer conductive layer. During this test, the DC voltage of a typically 4 to 5 kV for medium voltage cables, or about 10 to 12 kV for transmission cables, is applied to the neutral shield of the cable relative to earth ground. Note, the voltage is not applied to the cable insulation, and the cable insulation is not tested during this test. The metallic shield neutrals need to be completely isolated from Mother Earth. The ground connection of the instrument is then connected to earth using a suitable ground-earth connection, like a ground stake for example. This test is effectively a pass-fail test, testing the integrity of the jacket. Current should also be monitored during the test. A certain amount of current will naturally flow when performing a jacket test. The longer the cable, the larger this current. And it is important that the test instrument has sufficient current and voltage, i.e. power, to meet this, or you will get false negatives. The Digi Bridge has over 10 milliamps of current available, all the way up to 12 kV of applied voltage, suitable to test even the very long lengths of cable runs. The second mode is used to find the fault in the cable, either the fault in the cable jacket from the first test or a fault in the cable installation. This fault location mode will determine the exact location of the fault, effectively pre-locating where the fault is in the cable. This allows the user to quickly identify the location or section where the fault is, particularly useful when you have very long cable spans. The instrument has two special bridge techniques to locate the faulted section in the cable. This is particularly effective when you have a non-arcing resistive faults, dead shorts, jacket faults, etc., where other methods simply don't work. The unit will show the position of the fault in feet, meters, or percentage of cable length. Finally, the third mode is what we refer to as the cable jacket fault pinpointing mode. For direct buried cables or cables with conductive outer sheath, the operator can then use the Digi Bridge to locate the exact position of the fault in the cable using the optional A-frame receiver using the voltage gradient method. In this mode, a pulse voltage current is injected into the neutral shield of the cable by the Digi Bridge. A synchronized audible sound is also heard when the pulse is injected, assisting the operator. At the site of the fault, the current will escape from the jacket into the surrounding earth. This will cause a voltage gradient to be set up above the fault as shown. A special A-frame receiver with a very sensitive meter will then detect these signals as they propagate through the earth, allowing the operator to very precisely locate the defect site. The meter needle deflecting to the right tells the operator to move to the right. Deflecting to the left tells the operator to move to the left. And when above the fault, the needle will deflect either not at all or very little from side to side. All in all, the Digi Bridge offers the user the ability to set up, test and locate cable jacket sheath faults. In addition, it is well suited to locate those hard to find cable insulation faults, particularly when other more traditional methods are limited or simply do not work. We look forward to hearing from you and providing you more information on this new instrument, the Digi Bridge.